Hello, myself Ashwant. I am from Andhra Pradesh. I completed MSc Physical Chemistry at Andhra University, Visakhapatnam. After completion of my MSc, I worked as a teacher in a school which is located in my village. Okay, coming to my inspiration to become a teacher, Professor Nageswar Rao, who is formerly worked as a professor in Andhra University. Why I inspire him is I like his way of teaching and methodology and techniques used to explain a certain concept which is very understanding me. Okay, since their teaching has been fad for me. Okay, this is my introduction. Okay, coming to the topic, today I want to discuss about the topic is valency bond theory. What is okay? Today I am telling about valency bond theory. Okay, before entering to the valency bond theory, I want to discuss something about Westphal theory. Okay, Westphal theory fails to explaining the strength of the bonds. That means how strong is the bond, how weak is the bond between atomic orbitals. To overcome these two factors, valency bond theory was proposed. Firstly, valency bond theory was proposed by Mr. Hitler and London. Hitler and those scientists are proposed valency bond theory to explain the covalent bond formation between atomic orbitals. Explain covalent bond formation between atomic orbitals. After that, Slaughter and Pauling explain shapes of molecules and direction of the bonds in atoms. Okay, direction of the bonds in atoms. Okay, today I am discussed about in valency bond theory. Okay, covalent bond formation in atomic orbitals and what is sigma bond, what is pi bond, how they are formed with certain examples. Okay, coming to the first point. Is a covalent bond formed between two atoms. When two atoms are approaches to each other, when they are closely approaches to each other, one atom overlaps its valence orbital. One atom overlaps its valence orbital with the valence orbital of containing other atom having opposite spin. What is it? One atom overlaps with valence orbital containing unpaired electrons with the valence orbital of other atom containing unpaired atom having opposite spin. Okay, see, we see one example how it is. Okay, how the overlapping of orbitals are formed. Okay, first of all, hydrogen molecule. Take hydrogen molecule. In hydrogen molecule, there are two hydrogens is there. In both of hydrogens, two valence orbitals is there. Here valence orbital. In both, each orbital containing one unpaired electron. This is one unpaired electron. This is one unpaired electron having opposite spin. These two are combined to overlap and shared the electron pair equally. These two are combined to overlap and shared the electron pair equally. Here covalent bond is formed. Okay. Here one point is observed. What is that? The shared electron pair concentrated. This shared electron pair concentrated both the nuclei when they are overlapping, attracted with each other. Hence, both these bonds together. The shared electron pair concentrated between both nuclei when they are overlapping, so that these two nuclei are attracted with each other. So hence finally covalent bond is formed. Into the next point. Okay, between there is a greater extent of overlapping, stronger will be the bond. Suppose between two atomic orbitals they are greaterly overlapping, there will be a bond formed. It is the very strong. Stronger will be the bond. That is another point. Okay, sigma bond and pi bond formation. What is sigma bond? What is pi bond? Okay, a bond is formed between two atomic orbitals by an end-to-end overlapping. By end-to-end overlapping or head-on overlapping. A bond is formed between atomic orbitals due to the by end-to-end overlapping or head-on-head overlapping. Along with internuclear axis. First we know what is internuclear axis. Suppose two p orbitals are involved bond like this. Okay, an imaginary line bisects these two p orbitals, which is imaginary line. These are called internuclear axis. Okay, coming to the sigma bond. How the sigma bond is formed? By an end-to-end overlapping along with internuclear axis. Okay, so these two are end-to-end overlap. These two are in end-to-end overlapping. So here sigma bond is formed. This is internuclear axis. These two are these two are in end-to-end overlapping along with the intermolecular axis. Here sigma bond is formed. Okay. Here ends another point towards sigma bond. Sigma bond is very strong. Why? Because the shared electron pair in between two atomic orbitals, the shared electron pair concentrates both the nucleus, attracts both each other. So sigma bonds very strong. Next bond is pi bond. What is pi bond? Pi bond is formed due to the overlapping by lateral or sideways. Lateral or sideways in overlapping of two atomic orbitals, pi bond is formed. The pi bond is formed due to the lateral or sideways overlapping of two atomic orbitals. Here one point we will noted. These overlapping are done by with perpendicular to the internuclear axis. Perpendicular to the internuclear axis. Suppose these two pi orbitals. These are overlapping. This is sideways overlapping. These are perpendicular to the internuclear axis. This is internuclear axis. Perpendicular to the internuclear axis, pi bond is formed. Compared to sigma bond, pi bond is very. I given one example. Sigma bond and pi bond formation. I take N2 molecule. In N2 molecule, nitrogen configuration is 1s1, 2s, 1s2, 1s2, 2s2, 2p3. Okay, in 2p3, there is 3p orbitals. This is 2px1, 2py1, 2pz1. Okay, I write those p orbitals in bond formation. How the sigma bond and pi bond is formed. I wrote this. Okay, see directly write the overlapping of those three p orbitals. These two are end-to-end overlap. In nitrogen molecule, these two are end-to-end overlap. So here strong sigma bond is formed. Here these two are lateral or sideways overlapping. Here pi bond is formed. Here, so in that case, pz case also pi bond is formed. Here sigma px bond formed. Here pi py bond, and another one is pi pz. Okay. Here one sigma px bond and pi py bond and pi pz bond due to sideways overlapping. So finally we write the structure of nitrogen molecule like this. Nitrogen having totally 3 bonds, 1 sigma bond, 2 pi bonds. Okay, this is my topic.